Okay, these are the 9.2 notes, sum and difference identities, page 4. Now, A, cosine of 75. We've looked at this a couple of times. You use the calculator on page 1, on page 2. We did this as a sum. We wrote this as cosine of 45 degrees plus 30 degrees. The nice thing about these trig values is that there's always going to be multiple ways to get at what we want. So I'm going to look at this as the cosine of 120 minus 45 degrees. 120 degrees minus 45, because that is still 75 degrees. Okay, so now I have a cosine difference. And so I'm looking at this version, cosine alpha minus beta, which is going to be cosine alpha, cosine beta, plus sine alpha, sine beta. And so we've got cosine of 120 times the cosine of 45 plus the sine of 120 plus the sine of 45. Cosine of 120 is negative 1/2. Cosine of 45 is square root of 2 over 2. Sine of 120 is square root of 3 over 4. Sorry, square root of 3 over 2 times the sine of 45 square root of 2 over 2. I get negative square root of 2 over 4 plus the square root of 6 over 4. And because I would much rather have that positive first when I combine them over the 4, I'm going to write square root of 6 minus the square root of 2 all over 4. And that's the exact same thing we got on the first page, because you know what? The value of the cosine of 75 is not going to change, provided that we go at it using correct values. B, tangent of 105. So how can I make 105? We've got, I could go 90 plus 15. 90 I could work with, 15 I don't know. So I need to come up with a different way. So how about we go with tangent of 60 plus 45. That should work. So again, I'm going to write my formula out. Tangent of alpha plus beta is the tangent of alpha plus the tangent of beta all over 1 minus tangent of alpha tangent beta. That's going to be the tangent of 60 plus the tangent of 45 over 1 minus the tangent of 60 times the tangent of 45. Tangent of 60 stick these up here. At 60 degrees, sine is square root of 3 over 2, cosine is 1/2, so the tangent at 60 is square root of 3. Tangent is 45, again, sine and cosine are the same at 45, so we get 1. So I've got tangent of 60 is square root of 3, plus the tangent of 45 is 1. All over 1 minus the tangent of 60, still square root of 3, times the tangent of 45, which is 1. And just so I'm consistent, rational number first, irrational number second. I get 1 plus the square root of 3, all over 1 minus the square root of 3. Okay, sine of pi over 12, and this is where students start becoming a little unhappy. Not crazy about the fractions, don't like the pi in the fraction, don't like the fraction they don't know. Perfectly acceptable to figure out what the degree equivalent is here. Your unit circle is labeled with radians and degrees. So pi over 12, 180 divided by 12 would make this a 15-degree angle. I like being able to work with the fractions, so I will start by taking a look at that denominator. I could multiply 6 and 2. To get 12. So I got something times pi over 6 minus something times pi over 2. I have pi over 2's in my unit circle. I have pi over 6's. When I created my answer key, I wasn't looking at it that way. So I'm going to look for variations on pi over 3's and pi over 4's. If I want to make 1 pi over 12, first things first, I know that to get 12 in the denominator, I'm going to have to multiply down here by 4, to multiply over here by 3. 4 pi over 12 minus 3 pi over 12. This gives me 1 pi over 12. So I know that I can rewrite pi over 12 as pi over 3 minus pi over 4. I've got the sign of a difference. So I'm looking at sine alpha minus beta. Sine alpha, cosine beta, minus cosine alpha, sine beta. Hopefully by now you're getting comfortable with the values. We're looking for sine of pi over 3, cosine of pi over 4, minus cosine of pi over 3, sine of pi over 4, sine of pi over 3, this is in the first quadrant, positive square root of 3 over 2. Cosine of pi over 4 is positive square root of 2 over 2. Minus the cosine at pi over 3 is positive 1/2. Sine at pi over 4, square root of 2 over 2. I get square root of 6 over 4 minus the square root of 2 over 4, which gives me square root of 6 minus the square root of 2 all over 4. Last one up here on the top, tangent 11 pi over 12. Again, I'm going to look for some combination of pi over 3 and pi over 4. 11 pi over 12 is bigger than both of them, so I'm going to assume I'm adding. And so let's see what happens when I get that common denominator. I got times 3 here, times 3 here. That would be 3 pi over 12. Times 4 here, times 4 here. That would give me 4 pi. 4 plus 3 is 7. That's not big enough. But I've got a 3 pi in the second term. If I could make the first term an 8 pi, 8 plus 3 is 11, that would work. So I've got to write this as 4 times 2 pi over 3. 4 over 4 times 2 pi over 3. So my tangent here is the sum of 2 pi plus 3 plus pi over 4. So I'm looking for the tangent of alpha plus beta. Tangent alpha, sign in the numerator, matches the operation inside our parentheses over 1 minus The operation there is opposite what it is inside the parentheses. So we've got tangent of 2 pi over 3 plus pi over 4. I need the tangent of 2 pi over 3 plus the tangent of pi over 4 all over 1 minus that tangent of 2 pi over 3 times the tangent of pi over 4. Tangent of 2 pi over 3, that is in the second quadrant, so tangent's going to be negative because our sine is positive, our cosine is negative. It should look like our pi over 3 part, right? So tangent at 2 pi over 3, positive square root of 3 over 2 divided by negative 1/2. We get a negative square root of 3. Tangent of pi over 4 is 1. So I've got 1 minus that negative square root of 3 times 1. 1 minus the square root of 3 over 1 plus the square root of 3. And that's it. We are not worried in this case about rationalizing the denominator. Just looking for that exact value. Okay, so example 7, let's start something different. We're going to start it on the bottom of this page. We will continue it on to page 5. I've got the sine of alpha is 4/5, where alpha is between 0 and pi over 2. That puts alpha in quadrant 1 for us. So I'm going to draw that picture. So there are my axes. My triangle gets made so that my right angle is on the x-axis. May not look like a right angle, we're going to pretend. There's my alpha made at the origin with the x-axis. The sine of alpha is 4 over 5, that's opposite over hypotenuse. So this is 4, this side is 5. Again, our favorite Pythagorean triple, that makes this side 3. So I know my sine of alpha is 4 over 5. It should match what they gave me. My cosine of alpha is 3 over 5. We've got cosine of beta equals negative 12 over 13. Keep in mind if the cosine's negative, because our hypotenuse is never negative, that means we're in quadrant 2 or 3. They tell us that beta is between pi over 2 and pi, which means our beta has to be in quadrant 2, right? Because 90 degrees straight up, that's our pi over 2. 180 degrees, that's our pi. So I'm going to draw my triangle here with my right angle made with the x-axis. Angle B is right here, next to the origin. My cosine adjacent over hypotenuse is negative 12 over 13. So negative 12, 13. This is another one of our Pythagorean triples. You can check this out. 12 squared is 144. 5 squared is 25. 144 plus 25 is 169. Square root of that is 13, so I'm good. What do we have here? Cosine of beta. Negative 12 over 13. It should be. That's what they told us before. And our sine of beta is now 5 over 13 for this angle. These two angles do not have to be in the same triangle. They probably will not. That's perfectly fine. We just need the values of sines and cosines. So we've got sine alpha minus beta. And that is the sine of alpha, the cosine of beta, minus the cosine of alpha, the sine of beta. I don't have angles to put in here and rewrite this, so now I'm just going to fill in the values that we found. The sine of alpha over here, excuse me, is 4/5. Cosine of beta, negative 12 over 13, minus the cosine of alpha is 3/5 times the sine of beta, which is 5 over 13. I could cancel these 5s. I don't really want to. I'd kind of rather have a common denominator. I get negative 48 over 65 minus 15 over 65, which gives me a negative 63 over 65. And that is the value of our sine alpha minus beta. Keep in mind, alpha and beta are two angles. If I subtract them, I still get another angle. My value for sine of alpha minus beta should be between negative 1 and 1. So if I get something that is larger than 1 or smaller than negative 1, I know that I've made a mistake. Here we should be okay. You got negative 63 over 65, just a little off of that negative 1, but not below it.